Okay, the last part of this week's notes paper focuses on tangent lines, and it's also going to focus on the rate of change as it relates to like acceleration, velocity, things like that. So number 30, a tangent line problem. We've done problems like this before, where you have to figure out the slope of the tangent line at that particular point, which in this case is 1. So before we start the process of figuring out the slope, we also need a y value. So I only give you an x value. So if you remember, this x value of 1, if you plug it in here, that'll give you the y value at that, whatever point we're talking about. So if you fill in 1 here, you get 3 to the third, which is 27. So it's a pretty big number, all right? The first thing whenever you see a tangent line problem is you need a slope of that tangent line. So slope, if you remember, is the derivative. That means derivative. So you're going to take the derivative of that function. So this is the chain rule. So 3 times 1 is 3. 2x plus 1 is squared. And then you need the derivative of the inside, which in this case is 2. So now the slope, the derivative, is this formula. 6 times 2x plus 1 squared. So now to figure out the slope, you just plug in the point at 1, 27. So you plug in 1 into here, so you get 6, and then you plug in 1, you get 7 squared. You get 3 squared, which is 9. So the slope is 54, big number, okay? So then to figure out your b, you plug in your slope and you plug in your point. So the y guy is 27. Excuse me. The slope is 54, if I did that correctly. And your x is 1 plus b. So 54, and then you subtract it over. Actually, it comes out to negative 27 is your b. So the equation of the tangent line is kind of strange because the slope is a big number, 54. Put an x by it, and then, excuse me, the b is negative 27. So that's the equation of the tangent line of that equation at that point. So it has a really steep slope at x equals 1. All right, next one, excuse me, is kind of similar. So this one I give you the x and y value. So now the y value is e cubed. That's a little strange. So now we started getting into points that are a little more difficult rather than, like just kind of regular old numbers. So see if you remember how to take the derivative of a function e to the x, or in this case, e to the 2x plus 1. So the derivative of e to the x, or e to the whatever, is e to the whatever. And then you need the derivative of the exponent, which in this case is 2. So the slope, or y prime, is 2 e to the 2x plus 1. So the slope at that point, 1 comma e to the third. So now you just plug in 1 for x. So you get 2, and you plug in 1, you get e to the third. So this slope is really strange. You're plugging in 1 into here. 2 times 1 is 2, plus 1 is 3. So you get 2e cubed is the slope. So remember, e cubed is about 27. So the slope, again, is actually about 54 if you kind of put it in number terms. So now to get your b, you put in the y guy. The y guy is e to the third. Your slope was 2e cubed. Your x guy is 1 plus b. So e to the third equals 2e to the third plus b. So think of this as a number. You subtract it. And even though e is a number, the whole process here kind of works like a variable with e. Okay? So you subtract e cubed minus 2e cubed is negative 1e cubed. Your b. So the formula for the tangent line is y equals, the slope was 2e cubed, put an x there, and then your b is negative e to the third. So when you do a tangent line problem like this, the line does have a weird looking formula, okay, for the tangent line. All right, so now we get into derivatives as they relate to a motion. So what S is, if you're not familiar with this, S is a distance function, or it might be a height function, depending on things. So in this case, number 30, S is actually a height. So to figure out the velocity, you can see above, is what you do is you take the derivative of the distance function, the derivative of the height function. So our S in this problem, S of t, is what I give you, 160t minus 16t squared. So when you take the derivative, you treat t like an x. It works the same way. So you're taking the derivative this time, and this is kind of the first time we use this language with respect to t rather than respect to x. So the derivative of 160t is 160. The derivative of negative 16t squared is negative 32t. So then to get the acceleration, what you do is you take the derivative of the velocity function, which in this case is negative 32, right? Because the derivative of a number is 0. The derivative of negative 32t is negative 32. All right, so you can do letter A a couple different ways, okay? What you can do is, it says letter A, how high does the rock go? So it might be a little easier if you think about this logically. It says a heavy rock is blown straight up in the air with a launch velocity of 160 feet per second, okay? So the maximum height, when it reaches the maximum height, you could actually find the vertex of the distance function, but what I do is at the very, very top, the velocity is actually 0, okay? So when it gets to the very tippy top, when this rock is going up, at the very tippy top, right up here, the velocity is actually 0. So what I do is I set the velocity function equal to 0 to figure out the time, all right? So I just set it equal to 160 minus 32t. So then if you set it equal to 0, you can figure out the time in which this thing is going to reach its maximum. So that'll be negative, and then the negative 32 cancels, so it's just 32 with a t there. So some of these work out kind of nice. Some of them, in this case, 160 divided by 32. Let's do that. This one actually does come out even. It's 5. Okay, so at 5 seconds, it'll take to get to the very tippy top where the velocity is 0. Okay, so then you can figure out how high it is by putting in 5 into the height function, into the s. So 165 minus 16 times 5 squared, and you can figure that out. Some of these you do need a little bit of a calculator. So 160 times 5 is 800. Minus 25 times 16 is 400. So it looks like the maximum height is 400. Okay, that's what I usually do, is to find the maximum height, I usually set the velocity equal to 0. Okay, so it says, what's the speed and velocity of the rock when it's 256 feet above the ground, on the way up or on the way down, okay? So velocity may be negative depending on the direction. Speed is always the absolute value of velocity, okay? So it says when it's 256 feet above the ground. So what I do is you have to figure out time, and then you can just use the velocity function to figure it out. So In this case, our height is 256. All right. So we set that equal to 160t minus 16t squared. All right. So what I'll do is I'll get a 0 over here, and then so it'll be 16t squared minus 160t plus 256 equals 0. All right. So what you have to do then is you can factor actually a 16 out of here. So you get t squared minus 10t, and then the 16 divided by 256 is 16, right, equals 0. So this one actually factors into t minus 8 and t minus 2. All right. So you have to realize is it's going to reach 256 feet above the ground on the way up, because it's going to go up to 400, right? That's what we saw. And then it's going to go back down. So 256 feet above the ground is here. So this will be 256. And then once it reaches 400, it's going to go back down. So 256 feet is also over here. So you can see as time goes on, this would be time t equals 2 from down here. And then we'll also have a t equals 8. All right, so these are our two t's, which makes it 0. Over here, will be time equals 8. All right, so now they should have the same speed. Okay, speed is an absolute value. Velocity sometimes has a direction, whether it's going up or whether it's going down. So what you do then is you just put 2 and 8 into the velocity function. Right? So you put 2, and then you put 8 into the velocity function. All right, so up above, we had the velocity function. We had 160 minus 32t. So if you take 160 minus, in this case, when you put in 2, that'll be 64. You get 96. And this will be feet per probably second, I would imagine. Let's look up above. Yeah, per second. Okay, so that gives you a positive velocity, right? On the way down, the velocity will be negative because it's going a different direction. So this one, if you put in 160 and then minus 32 times 8, so you do 32 times 8, you get negative 256, and then minus 160 or add 100, you get negative 96. Okay? So they just determined, like on the way down, the velocity would be negative. But speed is just the absolute value of that. So speed is just the absolute value of velocity. So that would be just 96. So the speed at 2 would be positive 96. Excuse me, the velocity at 2 would be 96. The velocity at 8 would be negative 96. The speed at that would be 96, just the absolute value of it is. So it says, what's the acceleration of the rock at any time? The acceleration function we figured out above, the acceleration is constant, okay? It's constant. You could see the acceleration up here is negative 32. So that would be the acceleration. Right. And this is feet squared per second. All right. Okay. Next one is, it says, when does the rock hit the ground again? The rock's going to hit the ground again when the height is 0. So you're going to set the height equal to 0. So the height function up above was, I think it was 160t minus 16t squared, I believe. Okay, so let's check, make sure that's correct. Yep, minus 16t squared. All right, so you just set it equal to 0. So what you can do is you can factor out a t, and you can also factor out a 16, right? So the height will be 0 when it starts again down at the very bottom. So take out a 16t. So you have a 10 left minus t. All right. So one of the times you can see is 0. That's when it starts. So of course it's on the ground when it starts. And then the other t is 10. So when does the rock hit the ground again? At time t equals 10. All right. All right. Next one. This one only deals with acceleration and velocity. Here it gives you acceleration and velocity. Well, actually, just gives you velocity. All right. So let's find acceleration. Acceleration is just the derivative. So derivative of t squared is 2t. The derivative of 4t is 4. Okay. So with these types of problems, it's asking you when find the body's acceleration at each time when the velocity is 0. Okay, so now what we do is we want to find when the velocity is 0 first. All right, so you set the velocity function equal to 0. T squared minus 4t plus 3. All right, so when you get a problem like this on the exam, it will always factor. All right, so we got those. So at time t equals 3 and time t equals 1, that's when the velocity is going to be 0. So then we just want to find the acceleration at each of those times. So when a of 3 and a of 1, so you plug in 3, 2 times 3 minus 4 is 2, and then 2 times 1 minus 4 is actually negative 2, right? So a positive acceleration means it's speeding up. A negative acceleration means it's slowing down. That's all it means, okay? So it says, when is the body moving forwards and backwards? All right, the way you can tell when the body is moving forwards and backwards is velocity. So if it's moving forwards, that is a positive velocity. That's when it has a positive velocity. If it's moving backwards, that means it has a negative velocity. Okay? So what we did up above is we figured out when the velocity is 0, at what times. So make a little chart here. All right? So time starts at 0. And where the velocity is 0 is time 1. So right here, the velocity is 0. And time 3, the velocity is 0. All right? So in between those times is where it may change. All right? So it won't change anywhere else. It won't change positive or negative. So you have to find out where the velocity is 0. All right? So where it's moving forwards is where the velocity is positive. Where it's moving backwards, the velocity is negative. So what you do is you just kind of put a number in here into the velocity function to figure out if it's positive or negative. So if you put like a half in, okay, I would put it in the factored form, okay, right in there, right? If you put a half in, you get a negative. If you put a half in, you get a negative. Negative times a negative is a positive. You only care if the velocity is positive or negative. You don't care about what the number is, all right? So now if you put a number between 1 and 3 into velocity, like 2, if you put 2 in here, time t equals 2, you get a negative. If you put time t equals 2 here, you get a positive. Negative times a positive is a negative. And then if you put like a time like 4 in over here on the end, and this goes out to infinity. I just kind of stopped it here. If you put 4 in, you get a positive times a positive, which is a positive. All right? So now you can see where it's moving backwards and forwards. All right? So we'll just kind of put a little forwards here. And we're going to put interval notation and then backwards. All right? So forwards was positive. So between 0 and 1, it's positive, not including 1 because the velocity is 0 at 1. And then union, it's also moving forwards from 3 to infinity. All right? Not including 3 because the velocity is 0 at 3. Backwards is between 1 and 3. because the velocity is negative. All right. All right, so that's that. All right. Now, that's how you tell if a body is moving forwards or backwards based on its velocity. Okay, that velocity determines the direction of it. How you can tell if the velocity is increasing, that means the acceleration is positive. If the velocity is decreasing, that means the acceleration is negative. Okay? So if the velocity is getting faster, like you're going, 10 miles an hour, then 20, then 30, that means you're stepping on the gas. That means the acceleration is positive. If you're slowing down, if the velocity is decreasing, that means you're putting on the brake. You're coming to a stop sign, so the acceleration is negative. So now what we're going to do is we're going to set the acceleration equal to 0 to figure out where the acceleration is positive or negative. So the acceleration function was, up here, it was, I think, 2t minus 4, okay? So you set it equal to 0. So you get 4, and it's positive, 2t, so t is 2. So when t is 2, the acceleration is 0, right? So kind of the same thing. T is 2, all right? And the acceleration is 0. So between 0 and, whatever, at 2 is where it's going to change because that's where it's 0, okay? So same thing, you put a number in between here like 1. So if you put a 1 in the acceleration function, you get 2 minus 4, which is a negative. If you put in 3 or 4 or whatever you want into the acceleration function, you can see 2 times 3 is 6 minus 4 is a positive number, okay? So that tells you where the velocity is increasing. Okay? So velocity increasing and velocity decreasing. So we'll make kind of 2 things here, and then we're done. So the velocity is increasing. It's getting faster where the acceleration is positive. So from 2 to infinity. Not including 2 because the acceleration is 0. When the acceleration is 0, that means you're on cruise control. That means you're not speeding up or slowing down. You're going 55 miles an hour all the time. Decreasing would be between 0 and if you put a bracket for the 0, I wouldn't mark it necessarily wrong. It actually should have a bracket because at time 0, the acceleration is -4. So technically, I guess there should be a bracket there instead of a parenthesis. And I think up above, too, I think we may have to put a bracket there with 0. We'll revisit that in a minute. But it's going to be decreasing between 0 and 2, not including 2 because the acceleration is 0. So if you put in 0 into the acceleration function, you can see it is negative. So I think we're going to have to include 0 there. So let's kind of go back and adjust that. I think we're going to have to include 0 up here, okay? So if we put in 0 into the velocity function, you get a positive number, right? So I think we'll have to make sure we include 0 then. It's kind of a nitpicky thing. And, you could kind of say, well, time didn't even start, but if you put in 0 into velocity, you get -3 times -1, which is a +3. So you might want to include 0 there, okay? All right, so moving backwards or forwards, that tells you velocity. Velocity tells you direction. Whether the velocity is increasing or decreasing has to do with the acceleration. All right, that concludes that week on the different derivative methods and a little bit with rate of motion.